Okay, so partial fraction decomposition. Remember, we're going backwards. So every linear factor in the denominator gets a constant numerator, so that a, b, c, d. Every nonlinear or quadratic factor gets that ax plus b, so a linear factor on top. So the first thing we have to do is decide whether this is a reducible quadratic, so meaning I can factor it or not. So I'm going to come here to the side, and I'm going to attempt bottoms up. So I have x squared minus 9x. Remember, we give the 2 to the last term, which is a negative 10. So that gives me x minus 10 and x plus 1. Remember, it has to multiply to be the last term and add to be the center term. But we have to divide that 2 back out. So the first factor reduces to x minus 5, and the second factor we bring the bottom up, and we get 2x plus 1. Okay? Alright, so that means I'm going to have a over my first factor of x minus 5 plus b over my second factor of 2x plus 1. Okay? So remember, when we have an equation, the first thing we do every time is multiply each and every term by the common denominator. I'm going to do it this way. Hold on, I'm writing off the screen. Okay, so that is going to give me, this whole denominator goes away and leaves me with 3x plus 7 is equal to x plus 5, x minus 5 goes away, and leaves a times 2x plus 1, plus my 2x plus 1 goes away and leaves me with b times x minus 5. Okay, so then we now have to pick our values of x. So remember, it's a matter of what makes these 0 so that I only have one variable left in the problem. So I'm going to choose x equals 5 first. So that gives me 3 times 5 plus 7 is equal to a times 2 times 5 plus 1, and then 5 minus 5 is 0. So it's going to give me 22 is equal to 11a. So 2 is equal to a. Then I'm going to choose x is equal to negative 1/2. So it's 2x plus 1 equal to 0, and solve. So that gives me 3 times negative 1/2 plus 7 is equal to a times 0 plus b times negative 1/2 minus 5. It's going to give me 11 over 2 is equal to b times negative 11 over 2. So we multiply by the reciprocal, negative 2 over 11. And that gives me that b is equal to negative 1. So the last thing that I have to do is just to write it as my answer. So I write my original problem, 3x plus 7 over 2x squared minus 9x minus 5 is equal to a over x minus 5, so 2 over x minus 5, minus, just because this is a negative, I'm going to change this plus to a minus so that I don't have to put a double sign, 1 over 2x plus 1. And that's it. So we have 5x minus 1 over x squared minus 1. So we know that x squared minus 1 is a difference of two squares. So I have a over x plus b over x plus 1, c over x minus 1. Remembering that it doesn't matter what order you put a, b, and c in, or what they're over, it's all going to come out to be the same thing. So x minus 1, x plus 1, x minus 1, x plus 1, x minus 1, plus 1, and the same thing on the last term. Okay? So the whole denominator goes away and leaves me with 5x minus 1. The x goes away and leaves me with a times x plus 1, x minus 1, plus b. So the x plus 1 goes away, leaves me with x and x minus 1. And c, the x minus 1 goes away, leaves me with x and x plus 1. Okay, so then we need to pick our values of x. So I'm going to start with x equals 1. So I have 5 times 1 minus 1. So that the 1 is going to make this one go to 0 and this one go to 0. So I have a times 0 plus b times 0 plus c times 1 plus 1, which is 2. So I have 4 is equal to 2c. So 2 is equal to c. Then I'm going to choose x is equal to negative 1. So I have 5 times negative 1 minus 1. So that negative 1 is going to make this one go to 0 and this one go to 0. So I have a times 0 plus b times negative 1, negative 2, plus c times 0. So that'll be negative 6 is equal to 2b. So negative 3 is equal to b. And last, we have x is equal to 0. And x is equal to 0 is going to make this term and this term go to 0 and allow me to solve for a. So I have 5 times 0 minus 1 is equal to a, 1 times 1, b times 0, c times 0. So negative 1 is equal to a. Oh, this should have been a negative 1, negative a, and then a is equal to 1. So the last thing is to just write our problem back out. So 5x minus 1, x times x squared minus 1 is equal to a over x. So a is 1 over x. B is negative 3, so I'm going to do negative 3 over x plus 1. And c, so plus 2 over x minus 1. And that is my final answer. Okay, so the first two were case 1, and this is a case 2 because I have this repeating linear factor. So it is a case 2. So I have a over my first factor, b over the first instance of my repeated factor, and c over my repeated factor, the second instance of my repeated factor. Okay? So again, we're going to multiply everything by the common denominator, x minus 1, x plus 2 squared, x minus 1, x plus 2 squared, x minus 1, x plus 2 squared, x minus 1, x plus 2 squared. Okay? So the whole denominator goes away and leaves me with 9. X minus 1, so a times x plus 2 squared. One of the x plus 2's goes away and leaves me with b times x minus 1, x plus 2. And then both of those go away and leave me with plus c times x minus 1. So I'm going to start off picking my x values. So I have x is equal to, I'm going to pick negative 2. That negative 2 is going to make this factor and this factor go to 0. So I have 9 is equal to a times 0 plus b times 0 is equal to c times negative 2 minus 1. 9 is equal to negative 3c. So c is equal to negative 3. The only other value I can pick is x is equal to 1. And that's going to make this one go to 0 and this one go to 0. So I get 9 is equal to a times 3 squared plus b times 0 plus c times 0. So 9 is equal to 9a. So a is equal to 1. Now, in order to find b, we're going to have to expand this out and then group my like terms so I can compare coefficient to coefficient and so on and so forth. I'm going to show you the whole process, but we only need to know what the constant is. Well, we can use any one. I'm going to use the easiest one, which just happens to not be the constant, but I'm going to show you the whole process and you can choose what you want to do, okay? So the whole process would be 9 is equal to a times, so I'm going to expand that binomial. Remember, that we square the first term, twice the product, square the second term, plus b, x squared, plus 2x, and a negative 1 makes a plus x, minus 2, plus c, and I'm just going to distribute to that x minus 1, cx minus c. Okay, so I have 9 is equal to ax squared, plus 4ax, plus 4a, plus bx squared, plus bx, minus 2b, plus cx, plus minus c, minus c. Okay? Now, really and truthfully, we could stop here and just use this term because we know it has to be 0 because there's no square term on the left-hand side of the equation. But I just want to go through the process to show you how to group and factor these in the event that you need to find more than one. Okay? So, those two would go together. Then my x terms would go together. And then my constant terms. Okay, so let's do the whole process here. So 9 is equal to ax squared plus bx squared. I'm just going to put them together first. 4ax plus bx plus cx. And then 4a minus 2b minus c. Okay, so I have 9 is equal to a plus b times x squared. Now remember when I talked about in class, normally we would put the GCF out front, but because we're literally comparing coefficients from one side to the other, I'm going to write it like a coefficient, okay? And then I have 4a plus b plus c times x, and then this whole last thing is my constant. Now, I'm looking for b, which means I can use any of these three because all three of these had a b in them. But this is going to require me to plug in a and c. This one's going to require me to plug in a and c. This one is only going to require me to plug in a, and this one is going to be set to 0. This one is set to 0, and then this one would be set to 9 because this is the constant, this is the constant. There is no x term or x squared term on the left-hand side. That means that their coefficient is 0. So I would do a plus b is equal to 0. And I know that a is 1. So that means b has to be negative 1. So again, the last thing is to write out the whole problem. So I have 9 over x minus 1, x plus 2 squared. A was 1, so I have 1 over x minus 1. B is negative 1, so I'm going to do negative 1 over x plus 2. And C was negative 3, so minus 3 over x plus 2 squared. Okay. Okay, so this is another case 2 because I have the repeating factor of x squared. So I'm going to have then a over x, the first occurrence, b over x squared, the second occurrence, and then c over x minus 4. So again, the first thing I'm going to do is multiply to get rid of the common denominator. So x squared, x minus 4, x squared, x minus 4, x squared x minus 4, and x squared x minus 4. So the whole bottom crosses out at 4x squared minus 11x plus 12. One of the x's goes away. And then we have plus, so the squareds go away and leave me with x minus 4. And then the x minus 4 goes away and leaves me with just x squared. So now I need to pick my values. So I'm going to pick 0 first. Gives me 12 is equal to, so with that 0, any term with an x is going to have 0, so 0 and 0. So I'm going to have a times 0 plus b times negative 4 plus c times 0. So I have 12 is equal to negative 4b. So negative 3 is equal to b. Then my other one is going to be x equals 4. So plug and chug into the left-hand side and you get 32. I'm not going to waste time doing that. So any term with an x minus 4 is going to go to 0. So a times 0, b times 0, and plus c times 4 squared. So 32 is equal to 16c. So 2 is equal to c. So again, my only option at this point to find my missing numerator a is to expand. So that's going to give me 4x squared minus 11x plus 12 is equal to, so I'm going to expand that ax. So a times x is ax squared. And then a times x times negative 4 is negative 4ax. B times x minus 4b plus cx squared. So we're going to group and compare. So 4x squared minus 11x plus 12 is equal to, so we have x squared and x squared, an x and an x, and then this one is my only constant. So I have a plus c times x squared plus negative 4a plus b times x, and then minus 4b is my only constant. So 4b is so appealing right there, but I already have b. I need to find a. So I can use this one or this one. I'm just going to choose to use this one. It's a tiny bit less work, very tiny. Okay, so a plus c would have to equal, so these two coefficients have to be the same. So a plus c has to equal 4. And we know that the value of c is 2. So a plus 2 has to equal 4. Therefore, a has to equal 2. So then our last thing that we have to do is rewrite our problem. So 4x squared minus 11x plus 12 all over x squared times x minus 4 is equal to, so a is 2 over x, b was negative 3 over x squared, and c is 2 over x minus 4. Okay. Okay, so these last two are the type we're just going to set up, case 3 and case 4. So case 3, so we're only going to have to set this up. So this is a linear factor here, so it gets an a. So a over x minus 3. But this is a quadratic that doesn't factor or reduce. So it gets a bx, just going by the alphabet, bbc over x squared plus 2x minus 5. And that's it. That's all we do for that problem. I think I did a 4. I didn't do a 4, but it's the same thing. So we have 13x over these two. Both of these are non-reducible, non-factorable quadratics. So we have ax plus b over 3x squared minus 2 plus, so the cx plus d all over 2x squared minus 3. And I'll add a case 4 on here just to, if there wasn't one really on your paper, but I'll add one on there. So 2x plus 7 over x plus 4 times 2x squared minus 7. Okay? So the linear factor, again, the linear factor gets just a constant numerator. So that would be a over x plus 4 plus, then the quadratic, this should be squared, sorry. Then the quadratic gets the linear numerator, and because it appears twice, it has to have 2. So we have the first occurrence, bx plus c over 2x squared minus 7 plus, and then the second occurrence, dx plus e over 2x squared minus 7 squared. And just as a reminder, this is case 4. There just wasn't a good, I don't even know if there was one on your paper or not, but I don't think so. So I'm just going to add that one on there. Okay?